Hi there, so in this video I'm going to look at some slightly different trig equation questions. These are all ones that come up in the exams that have been seen as being a wee bit different from normal. Normally a trig equation you're simply asked a lovely straightforward question that looks something like this, and it will say solve 3 sine x plus 1 equals 2. And you'll change the subject, rearrange it, decide your boxes and go from there, alright? But every now and again there's questions that come in that are a bit different, and it's not straightforward that this is what you're actually being asked to do, is make a trig equation. Sometimes it's on a picture. So they've got the trig graph and they've got an intersecting line, or they're asking for a coordinate on it and you don't necessarily realise, oh, that's just a trig equation question. So that's what we're going to look at today. So the first style of odd question I found was one like this, and it's actually combining functions where it's the f of x substitution in. It's combining that but with a trig equation one. Now, part A, this would be in a calculator paper, but part A I'm going to get us to do without a calculator, because I want to just make us aware that this could be non-calculator, a wee 1 mark question like this. So it says we've got y equals 2 sine x. Now, first of all, I'm really sorry, that should have said f of x equals up here, so that should have said f of x equals 2 sine x. But f of x and y mean the same thing. And then it says calculate f of 90. So we know, hopefully from previous knowledge, that means we just replace x with 90. So f of 90 equals 2 sine 90. Now normally we just go type that in a calculator, but without a calculator, I'm going to ask you to picture your graph for a second. So here is a 2 sine x graph. It goes from 2 to minus 2. And it cuts at 180 and it cuts at 360. Now 90 is this bit right in the middle, so 90 is actually your highest point on the graph. Now on a 2 sine graph, the highest point is a number 2, right? So if you go along to 90, you go up to 2. The answer's 2, right? So 2 sine 90 is just 2. Similarly, I could have done that by just showing you that the original sine graph that goes from 1 to minus 1. So your normal sine graph goes as high as 1, but we've got a 2 in front, so we double it. So f of 90 is 2. So that's coming from your graph. Part B, it says f of t equals 0.9. So the first thing to notice is that x is turned to a t. So I'm going to rewrite that as 2 sine t. And they've put it equal to 0.9. So I'm putting that equal to 0.9. And then from there, look, that's just a trig equation, right? This is the one where you do this at the side to decide your boxes. So we've got a trig equation now, and the difference is we don't have x, so today we've got t. So the first thing, let's move that 2 over. So you've got sine t equals 9 divided by 2 is 0.45. Sine is positive, so I tick all in sine. So I'm using all in sine. My acute angle is when you do shift sine of 0.45. Remember, I always do it to the nearest whole number, so that's 27. So our acute angle is 27. Now we're actually going to be using our acute angle in this one because we're using all in sine. So in the all box, our answer is just 27. And in the sine box, it's 180 minus 27, which is 153. So they are the two possible values of t. Okay, so it's just a different way of asking you to recognise a trig equation question. Okay, so in this one we have the graph of the equation y equals 3 cos 2x. And we are told there are some coordinates on it to find p, q and r. Now it asks us to state the coordinate of the point p. Now state means there should be absolutely no working, okay? Now what we have to do is it's a 3 cos x graph that's been moved down. So number wise, that highest number would have been 3, but we've moved it down 1. So that highest number there is a 2. The lowest number would have been minus 3, but we've moved it down 1. So the lowest number would be minus 4. And then P is obviously the lowest point. Now in your basic cos graph, the lowest point is right in the middle. So that's 180. Now these notches on my little diagram, you see, shouldn't be there. Okay, that's a mistake of mine. So P is bang in the middle. So that's 180. Along, and it's down 4. So P is 180 negative 4. Okay, so the notches shouldn't be there, but you have to recognise, oh, that's right in the middle of the graph, that's 180. And it should have been at the point -3, but we've moved it down 1. So no working involved. That's part A. Part B asks us to find the coordinates of the point P, the points Q and R. Now, if you look at Q and R, they both lie on the x-axis, and we know that any point on the x-axis is along something up 0. So we need to find our x-coordinate. We know our y-coordinate is 0. So that's what we're going to use. We're going to sub in y is 0. So anytime you're asked to find roots of an equation, intersection of a line with the x-axis, you have to remember it's just a case of subbing in y is 0. Now, they could have worded this question differently. We've been asked for the coordinates of Q and R. There are other questions where it asks you simply find the points where the graph cuts the x-axis. So it's the exact same thing. So what we're going to do is we're going to replace y with 0. So part B, we're going to set y equal to 0 into the equation 3 cos x minus 1. Now, instead of just putting it on the left, I'm going to put it on the right-hand side because I know that people prefer to have our working on the left. So this is basically what we're now going to go solve. So from here, this is just solving your equation. So it's one of these. You're all sine, tan, cos again. So first time we're going to rearrange it. So we're going to move them 1 over. So we've got 3 cos x equals 1. That gives us cos x equals 1/3 when you divide by 3. Go solve that. So shift cos of 1/3 gives us an answer of 71 for our acute angle. Now, sorry, this was positive. So again, we are using all and all and cos for this one. So x will be 71, and it will also be 360 take away 71, which is 289. Okay, now they wanted coordinates, right? So just remember that Q was the first one. Now sometimes they ask for coordinates, sometimes they just ask for the x coordinates. This one wants full coordinates, so I have to write Q and R out. Now Q was the first one, so that means that Q was the 71, so along 71 up nothing, and R was along 289 up 0. So that is part B solved. Okay. My third example is very similar to the last one, but there's a slight difference to the second bit. So we've got the graph y equals 2 sine x plus 1, okay? And again, this one's better because it's not got any notches or numbers on the axis, other than it shows you the number 1 there to show where the graph started. So we want the coordinate of A. Now A is your maximum turning point. So the middle bit would have been 180. So the maximum turning point occurs at 90. Similarly, if they asked you for a coordinate down here instead, the lowest one, that would have been using 270, okay, by always finding the middle of 360 in the middle again. So we know that A is along 90. We just need to figure out how high it is. So it's the maximum point. Now your graph of y equals 2 sine x, the maximum point would have been 2, but they've moved it up 1, so the maximum is 3. The minimum would have been -2, but moving it up would be -1. So the coordinate of A is along 90 up 3. If I pretended to put another wee coordinate here and asked for that one there, let's call that D. D would be along 270 down to -1 using the same kind of steps. So let's look at part B. Part B says we've got a line, this red line here is the line y equals 1.5. Using that, we have to find the coordinates of the point B and C. So B and C are literally where the graph cuts with the line. So B and C are both occurring along something up 1.5. So our y value is 1.5. So all we're really going to do for part B is we're going to set y equal to 1.5. Now in my last example, I was setting y equal to 0 because my coordinates were on the x-axis. On this one, I'm just putting y equal to 1.5 because that's the line that's going through the graph. So that's what we're going to do. So we're going to do 2 sine x plus 1 equals 1.5. So 2 sine x plus 1 equals 1.5. We're going to take that 1 over. So 2 sine x equals 0.5. We're going to divide it by 2, so sine x equals 0.25. Now all sine, tan, cos, again, they're looking for the positive ones. It's just coincidence. Sometimes we'll ask for negative ones, but for my example, they're turning out as positive. So your acute angle, when you do shift sine of 0.25, you get the nearest whole number, you get 14. So my acute angle is 14. So in my all box, x is just going to be 14. And in my sine box, x is going to be 180 take away 14, which is, oh my goodness, 166. Now I'm just going to check the wording on this one. The wording wanted the full coordinates again, so that's fine. So B was your first coordinate. So the B one would have been along 14, and remember our line was 1.5 up. So it's along 14 up 1.5. C was along 166 up to 1.5 as well. So that's part B. So that's the kind of style of questions they're throwing in as well. Different ways of just presenting you with this, okay? That's normally what you're given. That's your nice one. This makes it a wee bit trickier by asking you to do it from a graph instead. So, thanks very much.